Hello, hi, hello everyone. Bienvenidos nuevamente. Bueno, el día de hoy vamos a dar paso a la lección 5 de nuestro curso, en el cual vamos a estudiar un tema muy importante que es el dibujo técnico, y en la gramática vamos a hacer un análisis nuevamente de adjetivos, pero en este caso para describir formas. So everyone, here we go again. Lesson 5, Technical Drawing. Objective. Introduce students to the basic technical drawing terminology, definitions, and instruments. In the design process, drawings are the main way information about an object or product is transmitted from one individual to another. Even if people do not speak the same language, anyone who understands the language of drawings will be able to interpret the information in them. For this reason, many concepts, symbols, and conventions have been approved, among other fundamental elements of this discipline. They have been standardized so that they have the same meaning no matter what language the user speaks. The purpose of this lesson is to give you the basic of sketching and drawing. I will use sketch and drawing as a single term. A sketch usually means freehand drawing. Drawing usually means using drawing instruments, from compasses to computer, to give precision to the drawings. Basic concepts of drawings. There are a number of basic concepts found in technical drawings. They are line types, or the alphabet of lines, symbols, dimensioning, notes, labels, and visualization. Line types. Object or visible lines. Thick dark line used to show outlines of an object, visible edges, and surfaces. In construction, drawings are the ones that outlines the structure or object, used for the main outlines of walls, floors, elevations, details, or sections. Hidden lines. Hidden lines are used to represent surfaces that are not directly visible in the orthographic view. Without hidden lines, all information about the features that are not directly visible will be lost. Whenever possible, show intersections and corners of hidden lines as touching lines, no gaps. There should be a gap at the transition between line types so that it is clear where one line type starts and the other one ends. Center lines or symmetry axis. Made up of a series of long and short, evenly spaced dashes, used to indicate the center of objects, arcs, and circles. You can add automated center lines to circles, arcs, ellipses, and patterns, including models with holes and extruded cuts, except mine plane extrusions. Picture and parts can also have automated center lines and center marks. Manual center lines. You can manually apply 4 types of center lines to individual features or parts in a drawing view. Center line to annotate the center of holes, circular edges, and cylindrical geometry. Center line bisector to create a center line that bisects 2 lines. Center patterns to create a center line on designs that have a consistent feature pattern. Note, if the pattern is circular, the center mark is placed automatically after you select all members. Break line. Break lines are used to show the beginning and ending of an object that has a pattern that repeats. Architects often use break lines when showing a set of stairs on a floor plan for a house or building. Extension and dimension lines. Extension lines extend from the part of the object being dimensioned, and dimension lines are placed in between the extension lines. Section lines. Section lines are used to show where a cross-section view of an object has been taken. The dotted portion of the line shows where the cut was made, and the arrows at each end indicate the direction that you look at the cross-section. Symbols. Symbols are used when it is to match information placed on the drawing. Symbols are available for all specialized areas of a drawing. Many symbols will look like the original object, but others will be stylized to represent the object. Dimensioning. The purpose of dimensioning is to provide a clear and complete description of an object. A complete set of dimensions will permit only one interpretation needed to construct the part. Dimensioning should follow these guidelines. Accuracy. Correct values must be given. Clearness. Dimensions must be placed in appropriate positions. Completeness. Nothing must be left out and nothing duplicated. Readability. The appropriate line quality must be used for legibility. Notes. Notes are exactly what the name implies. They provide additional information concerning a particular part of a drawing. There are some rules that have to be followed when using notes. They are: do not place notes on the drawing itself. Place them to the side. There should always be a leader line pointing the part in question. Do not use too many notes on one drawing. Labels. Labels are simple names attached to various drawings. They are used to identify views, sections, details, and drawing sheets in a series of drawings. Visualization. Visualization is the process of looking at a series of drawings that may include pictorial drawings and detailed drawings. By looking at all drawings as part of the whole object, you develop a mental image as to its overall size and shape. Pictorial drawings are three-dimensional drawings that look similar to a picture. There are two basic types, and they are isometric projection and oblique or theory of projection. Detailed drawings are also called orthographic drawings. An orthographic drawing is a series of two-dimensional drawings that show various views of the object. The views used most often are the front, top, and side. Isometric projection is a method for visually representing three-dimensional objects in two dimensions in technical and engineering drawings. It is an axometric projection in which the three coordinate axes appear equally foreshortened and the angle between any two of them is 120 degrees. The term isometric comes from the Greek for equal measure, reflecting that the scale along each axis of the projection is the same, unlike some other forms of graphical projection. Pictorial drawings. Oblique projection. Oblique projection is a method of drawing objects in three dimensions. It is quite a simple technique compared to isometric or even perspective drawing. However, to draw accurately in oblique projection, traditional drawing equipment is needed. In oblique projections, the front view is drawn through size, and the receding surfaces are drawn on an angle to give it a pictorial appearance. This form of projection has the advantage of showing one face, the front face, of the object without distortion. Generally, the face with the greatest detail faces the front. Detailed drawings. Orthographic projection. Another term for detailed drawings is orthographic projection. Here, the object is drawn as a series of drawings, each two-dimensional and showing one surface. By combining two or more of these surface drawings, you will build a visual image of what the three-dimensional shapes of the object is actually like. Generally, the front, top, and side view will be enough to show the shape of the object. However, you can use as many views as required. Keep in mind that the views must maintain their correct orientation. These two-dimensional views are used because they make it easy to add dimensions to the drawings. Take care and only use the number of dimensions necessary. Do not duplicate dimensions. With the orthographic projection, you also find a half-scale isometric drawing that completes the plan. For most objects that we draw orthographically, we only require the three basic views, called standard views: front side, right side view, top view. Sectioning. There are many times when the interior details of an object cannot be seen from the outside. We can get around this by pretending to cut the object on a plane and showing the sectional view. The sectional view is applicable to objects like engine blocks, where the interior details are intricate and would be very difficult to understand through the use of hidden lines. Hidden lines are, by convention, dotted on an orthographic or isometric drawing. Assembly drawings. An assembly drawing is needed for all products or inventions that have more than one part. These drawings list all parts and sub-assemblies that make the final product. A BOM, Bill of Materials, on the drawing lists each part, part name, and part quantity. Some of these drawings provide instructions on how to assemble the product at a manufacturing level, while others may list part number for consumers to reorder parts. Instructions may include information such as how to fasten parts together or what type of lubricant to use. We finally have the last two types of technical drawing. A cross-sectional view. A cross-sectional view portrays a cutaway portion of the object and is another way to show hidden components in a device. Half sections. A half section is a view of an object showing one half of the view in section. Drawing tools. To prepare a drawing, one can use manual drafting instruments or computer-aided drafted or designed or CAD. The basic drawing standards and conventions are the same regardless of what design tool you use to make the drawings. In learning drafting, we will approach it from the perspective of manual drafting. If the drawing is made without either instruments or CAD, it is called a freehand sketch. Drawing instruments are used to prepare neat and accurate drawings. To a greater extent, the accuracy of the drawings depends on the quality of instruments used to prepare them. The following is the list of drawing instruments and other materials required. Click on the following link to see a most-complete list of instruments. Important note: consider a 2H pencil for most lines of finished, darkened drawing, 6H for construction preliminary work, and 4H for center, hidden, and dimension lines. All finished lines are to be black. Also, consider metric lead and metric lead holders, 3 mm, 5 mm, and 7 mm, to avoid sharpening a pencil so often. As a conclusion, we can say that the term drawing may be defined as the linear realization of visual objects, concepts, emotions, and fantasies, including symbols and even abstract forms. Drawing is a graphic art which is characterized by an emphasis on form or shape, rather than mass and color as in painting. Drawing is quite different from graphic printmaking processes, because although a drawing may form the basis for replication, it is by its very nature unique. Now it's time to do the activities. Good luck!